All right, students. Now we will start the paper May, June, sorry, February, March 2026, paper 4, variant 2. This is the recent paper which we are going to start today. All right, we will start from question number 1. In this question, they are saying a student cycles from home to school. Figure 1.1 shows the distance time graph for this journey. So time is given in minutes and distance is given in kilometer. And this is the distance time graph which is divided into the different section from A to E. Now they are saying in part A, state the distance between home and school. So we have to calculate the distance between home and school. So you can see the student is starting from this position, that is the initial position A, and the journey will end at position E. So we have to calculate the total distance covered by the student. So it's a very easy question, and this type of questions can be asked in math paper as well. So now students, we will draw the straight line. So this distance is the distance traveled by the student. So well done, Hafsa. You can see it is 1.6 and after two boxes we will get 1.7. So basically the student has covered a distance of 1.7 kilometer. All right, students. So basically in part A is we have to find the distance between home and school. So the total distance covered by the student is 1.7 kilometer. So those who have joined late, let me tell you again, we have started the new paper today. This is the recent paper of Feb March 2026, paper 4, variant 2. This is the recent paper of this year, students. And in this question, we are given distance time graph and we have to calculate the total distance covered by the child. Now they are saying in part B, state one point A, B, C, D, and E, which identifies a time when the student accelerates. Accelerate means that the speed of the student is increasing. And in the second part, they are saying student decelerate. Decelerate means when the student speed is decreasing. All right, accelerate. So how can we find that whether in which section of the journey student is accelerating? So how can I find the students? देखिए बेटा, this is distance time graph. And with the gradient of distance time graph, we can find the speed. Or with the gradient of speed time graph, we can find acceleration. So how do I know whether the student is accelerating or not? So acceleration means if the gradient of any section is greater, so it means that student is accelerating. All right. If the gradient of any section is greater, so it means the student is accelerating. So in A to B, you can see, and the line is in this direction. If I check the B to C, so B to C line has a higher gradient. And look at the C to D. C to D line is steeper as compared to A to B and B to C. All right. And D to E speed is 0. All right, student. So it means if I compare all the sections, so this is the section at which the gradient is greater. All right. This is the section where the gradient is greater. So it means, student, if the gradient is greater, so it means the child is accelerating at this section of the journey. So it means the child will accelerate from point B. So what we have to write, students, in this option, we have to write here B is the point where the student is accelerating. Is it clear to you, students? I'm repeating, B is the point where the student is accelerating. Now, in the next question, they are saying we have to find when the student decelerate. Decelerate. So it means that we have to find the point where the student acceleration is decreasing. So we have to find the steeper line. All right, we have to find the steeper line. So you can see B to C line has greater gradient, so its acceleration is greater. But if I compare A to B and C to D, so in comparison between A to B and C to D, C to D has less gradient. Its gradient is steeper. If its gradient is steeper, so it means that its velocity is decreasing. Or if the velocity is decreasing, so it means that its acceleration is less. All right? Exactly, Hafsa, Inaya, Abdul Rafi. All right, at point C, acceleration. Well done, Ahmad. Ahmad, beta, we will write C, I think Ahmad or Abdul Rafi. Abdul Rafi. Abdul Rafi, we will write C. At point C, the child is decelerating. So it means, beta, for acceleration, we will write B here. All right. And for deceleration, we will write C here. Is it clear to you, students? Now look at the part C. In part C, they are saying use figure 1.1 to calculate the student maximum speed in kilometer per hour. So we have to calculate the student maximum speed in kilometer per hour. You can see beta, the time is given in minutes and the distance is given in kilometer, but we have to calculate the speed of the child, a student, in kilometer per hour, and we have to calculate the maximum speed. So maximum speed doesn't mean that we have to calculate the total speed or average speed. Maximum speed means we have to calculate the speed at which the gradient is greatest. So you can see, as I have already told you, that the gradient is greatest in this section of the journey from B to C. So it means that the students, if the gradient is greatest here, so speed of the child is greatest at this journey. So we have to calculate the speed here. So to calculate the speed, beta, we will use the formula of gradient. And what is the formula of gradient? Formula of gradient is equals to rise over run. All right. So to calculate this gradient, beta, to calculate this gradient, we have to take the initial time and initial speed, and we have to take the final time and final speed. All right, students. So now this must be initial time T1, which is 5 minutes, and the final time T2. We can take X1, X2 or T1, T2, whatever, beta. If you are confused, so I can write here X1 and X2 as well. X1 value is 5 minutes or X2 value is 7.5 because it is lying between 5 and 10. So it is 7.5. And what is the value of Y1, students? You can see the Y1 value is 0.4 and Y2 value is 1.25. Okay, students. So now what is the formula of gradient? Gradient formula is rise over run. Okay, so rise means Y2 minus Y1 divided by x2 minus x1. So by the gradient of this line, beta, we can find the maximum speed of the child. So now students, 1.25 minus 0.4, it is given in kilometer, divided by 5 minus, oh, sorry, beta, 7.5 minus 5. So now students, basically this time is given in minutes. So we have to convert the time from minutes to hours. So 7.5 minus 5 means 2.5 minutes. So how can I convert the minute into hours, beta? We have to convert the minute into hours. So how should I do this conversion, students? How should I do this conversion, everyone? Divide by 60. Exactly. So there are 2.5 minutes. So 2.5 divided by 60. What we will get, everyone? Okay, Hafsa. Yes, Abdul Rafe, mark scheme is not uploaded on any drive link on any. In fact, I have checked the school support hub of Cambridge. Basically, I have a membership of a school support hub, but I cannot find a mark scheme over there. All right. So that's why I'm discussing this paper in class, beta. Acha, tell me, students, what time we are getting in hours? 2.5 divided by 60. Hurry up. 2.5 divided by 60, what we will get, students? Come on. 0.0416. All right. Thank you, Abdul Rafe. All right, hours. So now, student, we will put the values in this formula of gradient. Okay, so 1.25 minus 0.4 divided by 0.0416. So what is the value of gradient? Gradient, we are getting 20.4. So basically, gradient is the maximum speed of the child and the unit is in kilometer per hour. Did you understand this question, students? All right, please note down this calculation, Vida. Done? All right. Now I'm moving towards the next question or next part. What they are saying in the next part. Acha, we have completed the question number one. This question was very easy. Now I'm moving towards the next question, which is question number two. So in question number two, they are saying figure 2.1 shows a ship made up of steel floating on the sea. So this ship is made up of steel. In A part 1, they are saying state the equation that links density, mass and volume. Exactly, everyone. What is the formula of density? The formula of density is basically equals to mass upon volume. All right, students. So it's very easy. In state question, you don't need to write a detail. Just you have to mention the formula or statement, whatever they are asking. Okay. So density is equals to mass upon volume. Done, everyone? Now look at the next question. In the next question, they are saying the density of steel is 7900 kg per meter cube. So basically what they have given us, the density of the steel is 7900 kg per meter cube. The mass of the steel cube is given 110 kg. Now we have to calculate the volume of the steel cube. So now students, to calculate the volume, we will use the same formula which I have mentioned here. Density is equals to mass upon volume. Now we will make the volume independent. So volume is equals to mass upon density. So mass is basically 110 and density is 7900. So after division, what we will get? We will get 0.014. And in Aya, we will not get the answer in centimeter cube, beta, because you can see the density unit is given in kg per meter cube. So density is given in kg per meter cube. So it means we will get the volume in meter cube. Exactly. All right, students. So volume of this solid steel cube is 0.014 meter cube. Did you understand this question, everyone? All right. Now I'm going to clear the screen and I'm moving towards the next part. In the next part, they are saying the density of the sea water is 1030 kg per meter cube. All right. So this is the density of sea water. Now they are saying state why the steel cube sink when placed in sink sea water. So basically, it's a very easy question, beta. What is the density of the steel? The density of the steel is given in the previous part, that is 7900 kg per meter cube. Exactly, students. So density of steel is 7900 and density of sea water is 1030. So you can see the density of steel is much greater than the density of water. So obviously the steel cube will sink into the water. So how will you write the answer that the steel cube has a greater density than sea water? All right, I'm writing here, beta. Steel cube has greater density than sea water. So it will sink into the water. Clear, students? So this question has only 1 mark weightage. So just I wrote one line statement which is clearly satisfying the question of this a question of the examiner, that the steel cube density is greater than seawater. Density spelling is incorrect. It's just a typo error, beta. Now look at the next part. In the next part, they are saying explain why the steel ship in figure 2.1 floats on the seawater. So that is the interesting thing. The interesting thing is the cube is made up of steel, but the cube is sinking into the water. And the ship is also made up of steel, but ship is not sinking into the water. So what is the reason behind this? They are using the word explain. So explain means we have to write the detailed answer that why the steel ship is floating on the surface of water or the steel cube is sinking into the water. What is the reason behind this? So basically, beta, Hafsa, we will not talk about the pressure here. So it's all about density. So basically, a steel shape is hollow inside. Okay, steel shapes are hollow. It is hollow inside and contains air. All right. So I'm writing the answer on my screen, beta. Just give me 1 minute. Okay. Now I'm writing here, steel shape is hollow and contains air. So basically, when the steel shape is hollow and it contains air, so it means that the volume of the ship is greater. All right. So when the volume of the ship is greater, so overall density of the steel ship is decreased. So we can write here overall density of the steel ship is less than the density of water. So that's why ship is floating on the surface of water. So देखिए बेटा, for 2 marks I wrote two valid statement here. The first statement is steel ship is hollow and contains air. So that's why it is increasing the volume of the ship, and density and volume are inversely related. So if the volume is greater, so it means that the density of the ship is less. So basically it is containing air inside it, so which will increase the volume and it will make it less denser. Is it clear to you, everyone? All right. I hope everyone is noting down each and every point in your register, because you will not find mark scheme anywhere, beta. So whatever points I'm discussing with you, these points are very important. Okay. Now I'm moving towards the next part, part B. In part B, they are saying the mass of the ship is 3.5 into 10 raised to power 7 kg. So now I'm making data here, students, that the mass of the ship is 3.5 into 10 raised to power 7 kg, and the acceleration of the ship is given, which is 0.75 meter per second square. Now they are asking to calculate the force which causes the acceleration. All right, so it means they are talking to calculate the resultant force. So which formula should I use here, students, to calculate the resultant force? Exactly. F is equals to ma. Well done. So we will use the Newton's second law of motion to calculate the resultant force. So F is equals to ma. So mass of the ship is 3.5 into 10 raised to power 7, and acceleration is given 0.75. Now multiply both of them, everyone, and tell me what answer we are getting. Okay, well done, students. So we are getting beta 2.6 into 10 raised to power 7 Newton. I am repeating the resultant force which is acting. Why it is for 2 marks? 1 mark is for formula and 1 mark is for calculation, because unit is already mentioned. Yeah, I know it's a one-step question, but if you will not write the formula, the examiner will deduct your 1 mark. Examiner will deduct your 1 mark. So that's why, beta, you have to mention the formula as well. All right. Obviously, Vanya, if you will not write the formula, so examiner will deduct your marks. All right. Whenever the calculation is given for 2 marks or 3 marks, remember that you must have to write the formula. All right. Okay, students. So we are getting the resultant force 2.6 into 10 raised to power 7 Newton. Are you understanding these questions, students? All right. Now look at the next part. In the next part, which is the last part of this question, 1 minute, students. Oh, sorry, beta, sorry. So basically, this question they are saying explain why the force provided by the ship engine must be larger than the value in 2B part 1. So what they are asking in this question that we have calculated the value of force that is 2.6 into 10 raised to power 7 Newton. But actually, the actual value is greater than this calculated value. So what is the reason behind this? Why we are getting the greater value than this calculation? So basically, when we are doing this calculation, we are not considering any type of backward force. So this is the ship beta. Forward force on the ship is the driving force with which the ship is moving in the forward direction. So what could be the backward force beta? Yes, Hafsa, backward force is water resistance. And water resistance is called drag force. Okay. Water resistance is called drag force, which we do not consider in this calculation. So if I ask you to find the resultant force, so resultant force must be the sum means these two forces are acting in the opposite direction. So we have to cancel these two forces. So driving force minus resistive force is the drag force. So after subtraction, we will get the resultant force and this resultant force will become less. So it means the students in actually the ship need to put the more force because the ship needs to overcome this resistive force as well. So it means beta the ship need to put more driving force. Sorry for interruption, students. All right, so I was explaining you the last part. In the last part, basically, what they are saying that why the ship in actually the ship engine must putting the larger value as compared to this calculation. What is the reason is that reason behind this? The reason is that the engine is providing extra force because it is performing work against the resistive force of water. So how we will write the answer, students? Engine must provide extra force to work against resistive force of water, and resistive force of water is called drag force. All right, students. Engine must provide extra force to work against the resistive force of water, and that resistive force is called drag force. So that's why, students, the drag force, due to the drag force, the engine is putting more force. So the in actual force is greater. Acha, one more thing which I want to add here, that the drag force which is acting on the ship is in the opposite direction, and this drag force will become greater as the speed of the ship is increasing. So now we can write the next point here as the speed of ship is increasing, drag force will also increase. It means engine will put more force. Engine needs to put more force. All right, students. So I'm repeating, as the speed of the ship is increasing, drag force will also increase. It's similar like the air resistance. All right, as the speed of the ship is increasing, so drag force will also increase. So as the drag force is increasing, so it means that engine need to put more force to overcome this resistive. Did you understand this question, students? Please note down this answer. All right, so we can move towards the next question. Done, everyone? All right. Now I'm moving towards the next question, that is question number 3. In question number 3, they are saying figure 3.1 shows a polar bear and a person standing on thick ice. The figures are drawn to a scale of 1 centimeter to 100 centimeter. देखिए बेटा, this type of questions we usually do in mathematics as well. All right, in drawing, the scale is 1 centimeter, but in actual location, the scale is 100 centimeter. Now they are saying the figure 3.1 contains, table 3.1 contains information about the polar bear and the person. Mass of the polar bear and person is given, area of contact with the ice is given. Now they are asking to calculate the weight of the polar bear. So it's a very easy question, student. What is the formula of weight, students? What is the formula of weight? W is equals to mg. Exactly. We will use the formula W is equals to mg, and we have to calculate the weight of the polar bear. So we will take the mass of the polar bear, which is 590 kg. All right. And the gravity value is 9.8. So after multiplication, we are getting 5,782 Newton. Well done, students. 5,782 Newton is the weight of the polar bear. All right. Well done, Hafsa. Well done, Inaya. Are you understanding these questions, students? Now, in the next part, they are saying calculate the pressure that the polar bear exerts on the ice. So, we have to calculate the pressure of the polar bear. So, first of all, tell me what is the formula of pressure, students? Exactly. I'm writing on the left side of a screen, beta. Pressure formula is force upon area. So what is force here? Force is basically the weight of the polar bear. So weight of the polar bear is 5782, and the area with which it is making contact with the ice is 1.12. So, Abdul Rafiq, thank you, beta. So, after division, we are getting 5256.36 Pascal. All right, beta. So, pressure which the polar bear is exerting on the ice is 52. Acha, Abdul Rafiq, I think check your calculation, because Inaya is giving me some different answer and I am also getting different answer, beta. Abdul Rafiq. No, Abdul Rafe, I am also getting this answer, beta. 5162.5 Pascal. Check your calculation again, Abdul Rafe. Okay. 5162.5 Pascal. Done, students? So this calculation is very easy. All right. So I hope you all have noted down this calculation. Now I'm moving towards the next part. What they are saying in part 3, use the numbers to complete each equation. Each number may be used once or more than once or not at all. Okay. Mass of polar bear is equals to mass of person. So we have to find that how many times the mass of polar bear is greater than the mass of the person. So you can see this table. Mass of the polar bear is given 590, and mass of the person is given 84. So we will use that technique of mathematics. All right, well done, beta. Mass of the polar bear is given 590. We have to find x here, and the mass of the person is given 84. So what we will do, we will simply do the division 590 divided by 84. So how many times the mass of the polar bear is greater, students? Well done, everyone. Seven times. So this is a little bit different question. Such type of question I have seen first time. So mass of the polar bear is 7 times the mass of the person. Well done. Now look at the next part, beta. Area of polar bear in contact with the ice is equals to area of person in contact with the ice. So again, we have to use the same strategy to find this question, beta. So what we will do, we have to find that how much times greater area of contact the polar bear is making with the ice. Polar bear contact of ice is 1.12 is equals to x times person contact of area is 0.020. So 1.12 divided by 0.020. So what we are getting, students? 56. Well done. 56. So basically, the surface area which polar bear is making with the ice is not Pascal, beta. Zurace, we cannot write Pascal because we are just finding the number that how many times area of contact of polar bear is greater than the area of contact of a person. So it is 56 times greater. 56 times greater. Is it clear to you, students? It seems like we are solving the math paper, not a physics paper. All right. So basically, the area of polar bear is 56 times greater than the area of contact of a person with ice. Now they are saying pressure exerted by person is equal. Now they are using the word person first. Pressure exerted by person is equals to pressure exerted by the polar bear. So now student, first we have to calculate the pressure of the person. So we are able to find this value. Okay. So what is the value of pressure of the person? So first we will find the pressure of a person, students. So we will use the formula force upon area. So force is basically the weight of the person. So force is basically the weight divided by area, and weight equals to mg upon area. So mass of the person is 84, gravity is 9.8, and area which the person is making contact with the ice is 0.020. So now student, what pressure the person is exerting on the ice is 41160 Pascal. Well done. So this is the pressure of man on the ice. So now we have to do the comparison between the pressure of man and the pressure which the polar bear is exerting on the ground, on the ice. So we have to find the x here. All right, student, I'm not going to clear this calculation. You can see the pressure exerted by the person is 41160 equals to, we have to find this x. So what was the pressure exerted by polar bear? So the pressure exerted by the polar bear was 5162.5. So we will move this term on the left side. So it will become 41160 divided by 5162.5 is equals to x. बेटा आप लोगों ने उल्टा डिवाइड किया है इसको. वी हैव टू मेक एक्स इंडिपेंडेंट ना. एक्स को इंडिपेंडेंट बनाना है तो इस वाली टर्म को हम दूसरी तरफ भेजेंगे. ठीक है. तो 41160 को डिवाइड करेंगे 5162. हाँ सही किया बेटा, सही किया. सॉरी, इट्स माय बैड. सो एक्स वी आर गेटिंग हियर 8. ठीक है. आई एम ऑल्सो गेटिंग द सेम आंसर, स्टूडेंट. So the man is exerting 8 times greater pressure as compared to the polar bear. Can anybody tell me what is the reason behind this, that why the man is exerting the greater pressure as compared to the polar bear, although the mass of the polar bear is greater than the mass of the person? Exactly, less surface area. Surface area is less, so it means that the pressure is greater. Students, did you understand this calculation? All right. Now I'm going to clear the screen, students, and let's move towards the next part B. In part B, they are saying under the ice is sea water with a density of 1030 kg per meter cube. So density of ice is given. Density symbol is rho, which is 1030 kg per meter cube. Now we have to calculate the change in pressure between the top of the sea water and the depth of the sea, which is 2.50 meter. So depth means the height of the sea is given 2.50 meter. So how we will calculate the change in pressure, students? Let's suppose that this is the surface of ice and this depth of is 2.50 meter. So we have to calculate the pressure at this point, which is at 2.50 meter deep. So what is the formula of pressure, students? Pressure due to liquid. What is the formula of pressure due to liquid? It is rho GH. Rho is the density, G is the gravity, and H is the height. Height means depth of the liquid. So density is 1030, which is the density of seawater. Gravity is 9.8 and height is 2.50. What answer we are getting, everyone? Exactly. We are getting 25235 Pascal. Is it clear to you, everyone? Well done, students. Okay. So we have done completed question number 3. Now I am moving towards the next question, that is question number 4. In question number 4, they are saying an outdoor heater warms people sitting outside. Figure 4.1 shows the heater. So you can see this is the outdoor heater. This type of heater has been given in the previous past paper questions as well. State the method of thermal energy transfer that warms the pupil. देखिए बेटा, there are three methods through which energy can be transferred. Number one, conduction. Number two, convection, and number three, radiation. But we have to find through which way the energy is transferred. So Abdul Rafi, convection will not occur, beta, because in convection, warm air always rise up and cold air always sink down. So because of the Acha, okay, Ahmad, 1 minute, beta. So basically, in the process of convection, warm air always rises up. So how the heat energy will reach to the person? Because the person is sitting below this heater. All right, Abdul Rafi? Person is sitting below this heater. So it means there is only one way through which the energy can be transferred, that is radiation. All right, radiation is the only one way through which energy can be transferred. Understood? And radiation means infrared radiation. Heat is transferred in form of infrared radiation. Is it clear to you, students? All right. Okay, Ahmed is asking question number